Once again, good morning. And today we will learn about combined variation. That's in lesson 3.4. We are now down to the last lesson for chapter 3 on variation. So let's have a very brief review. We have the first one is on, who can remember? What's the first variation that we have tackled? Anybody?
Direct variation, ma'am.
Very good, direct variation. How about the second one? How about the second? Oh, very good, Jared. Inverse variation. How about the third one? Can you remember? You can tell me what the third type is. Very good, Carmela. We have the joint variation. Now, to start with, let's have our memory verse. And today's memory verse is found in Philippians 4, verse 19. It says, "And my God will supply every need of yours according to his riches and glory in Christ Jesus." Our VCA boosters today is about faith. And faith is a combined variation. Now think of the factors, of the variables that will directly affect our faith. And think of the factors that will inversely affect it. And we'll write it as a combined variation. Now, at the end of today's class, we'll be able to illustrate situations involving combined variations, translate a variation statement, and the third one is we solve problems involving combined variations. Let's start with our venture activity. Remember last time, we have talked about the harvest story. Now, think, what will be the possible factors? Can you tell me what possible factors will affect the number of our harvest days? Anyone? What do you think can make the harvesting days faster? You say if there are more workers, then we'll have less number of harvesting days. Very good. What else? What variables can make the harvesting days faster? Or we only have few harvesting days? Oh, very good, Jared. If we have more work time, then harvesting days will be lesser. Now, another, what do you think will inversely affect it? What do you think will make the harvesting days longer? Can you tell us what will make the harvesting days longer? Very good, less workers. What else? Sometimes they say the size. If the size of the farm is big, then we need to have more harvesting days. Now, how do we write this in a combined variation? We say harvest days is equal to K, don't forget K. Now, the size is a direct variation. The larger, more harvesting days. So K times the size, while the workers and the time are inverse over workers times time. Okay, now here in our equation, we have the direct variation and two inverse variations. A combination of these two is called combined variation. Now, what is a combined variation? A combined variation defines a relation between three or more variables that vary directly and inversely. Let's have a very brief review. In direct variation, if one variable increases, the other variable increases. Or if both decreases, they do. In inverse variation, if one variable increases, the other variable decreases. In joint variation, if one variable increases as the other increases, then the other will also increase. It's a combination of two or more direct variations. Now in combined, here, if one variable increases, then the other variable will also increase. But there's a possibility that with reference to another variable, it will also decrease. Now, what is the general form of our joint variation, combined variation? That is y equals kx over z. Remember that x is our direct variation, while z is our inverse variation. And k should be non-zero, and x and z should not be equal to 0. Now, example, y varies directly as x. We write the first one. Y equals kx. And inversely as z. So over z. Let's have some examples. Okay, let me see who is in the room. Okay, let me start with the first 2, 4, 5 who are with me in the first page. The first one, AP. The second one, Carmela. The third one, Syra. Okay, if you want to write on my board, you can go on and write. The next one is Tatiana. And the last one is for Jared. Okay. Now, let's do translation. Ready? I'll give you 1 minute to write your answer on my board. How will you do it? Annotate. On top, you click annotate, then draw. Okay, you can start now. Okay, Syra, you can just direct message me for your answer. What happened to that, AP?
It's stressful writing with your fingers.
Because you're using your
I'm-
phone. Actually, AP, when you annotate, you can make it smaller.
It's so stressful.
Like when you annotate, you can have the size. Okay, let us check.
What? It's
Ah.
T. It's T equals A D. AB.
AB, like this one? Like this, AP?
Yes.
Review your answer.
You mean K equals T
How
equals
about Syra?
KB.
Oh, Tatiana, where are you going there? For Syra, I'll write her answer. I equals KV over R.
Oh, the answer is T equals KA over B.
Well, that one.
Sorry, I got
That's
confused.
okay. Let's wait for Tatiana.
Ma'am, I'm having a hard time writing
Yes,
this.
here, you can tell me your answer. I'll write it. V
Okay po.
cos.
V equals KT over P.
Oh, very good. Now let's start. Ready? T varies directly as A. So T equals Ka. And inversely as B. So over B, correct. Next, Z varies jointly, it means directly, as X and Y. Very good. And inversely as W. Very good, Carmela. Next, for Syra, the current I is directly proportional to the voltage V and inversely to resistance. Very good. Volume, directly as temperature, KT, and inversely as pressure over P. Very good. The time T, let's just write it as small t, Jared. T equals directly as the length of the road. Very good, KL. But inversely as the number of workers. Very good. That's how you do your translation. I told you, right? This lesson is very easy. Now let's go to the next one. In the next part, we'll be solving. Let me first clear the board. Now, if y varies directly as the square of x and inversely with z, the first thing to do is we need to write it in as a mathematical equation. So we say y varies directly with the square of x. So y equals kx squared, and inversely with z over z. Now, what are we going to do? If x equals 2, y equals 1, and z equals 10, find y when x equals 4 and z equals 5. You check the first given. In the first set, k is missing. So let's first solve for the constant of variation k. So let's substitute. Y is 1. K is missing. X is 2 squared over 10. So let's cross multiply. 1 times 10 is 10. 2 squared is 4, was 4k. We divide both sides by 4. So we have k equals 10 over 4, or that is 2.5, or 2 and 1/2. No, we already have our k, right? K is 2.5. Let's solve for y. Use your mathematical equation again. Y equals kx squared over z. Our k is 2.5. Our x is 4 squared. Sorry. All over 5. So you have 2.5 times 16 divided by 5. That is 32 plus 8. 40 over 5. So our y is equal to 8. Do you have any questions? Or give me a thumbs up if you're doing if you're following me. Oh, very good. Now let's go to the next one. I'll check first. There, I'll check how many problem I have. Okay, so 4 only. Let's go to exercise number 3. Wait for a moment. Okay, in your chat box, can you write the mathematical equation? In the chat box, write the mathematical equation for the time it takes to construct a highway varies directly as the length of the road, but inversely as the number of workers. Ready? In the chat box. Anyone? Very good, Jared and Maria and Carmela. We have T equals KL over W. Very good. That's very important to write it. Sorry. T equals KL over W. Now, here's the problem. If it takes 50 workers, let me write here. There are 50 workers, 8 weeks to construct. The time is 8. 2 kilometers of highway, the distance. Now, how long will it take 80 workers to construct 15 kilometers of highway? We have our time, we have the length of the road, and we have the workers, but our K is missing. So using the first set of data, let us solve for K. Solving for K. Now we have our T is 8. K, our length is 2 over our workers is 50. Cross multiply 50 times 8. That's 400 equals 2K. Equals 2K. Let me transfer here. Divide both by 2. So K equals 200. Now what can be 200? What's the unit of measure? It's not stated here, but in case this will be a number of days, so we say it will take 200 and 200, not, there. Our K is 200. R is in weeks, not days. Sorry. Now, let's remember K equals 200. So we have K equals 200. Let's solve for the second problem. How long will it take 80 workers? So we have 80 workers now to construct 15 kilometers of highway. The length is 15. Now here's a technique. Be sure that you have the same
The module.
of measure. For example, sorry. For example, if we have workers here, we also have workers here. If we have kilometers here, be sure that the first given is also in kilometers. In case they are not the same, like the first is in kilometers, the next is only in meters, be sure to convert so that both of them will have the same unit of measure. And for here, our time is in weeks. So the answer will be in weeks. Now let's start solving. That will be time equals K, let's go back, KL over W. So we have just here. K is 200, L is 15, W is 80. I'm sorry, I don't use calculator so much. So I'll keep on doing this. So 15, that's 150 divided by 4. 75 divide 2, that's 35, 37, 37.5. So the answer is it will take 37.5 weeks. Any questions? Or give me a thumbs up if you have followed it. Very good. Feel free to raise your hand if you have answers, okay? Now let's go to the last example. Now in the chat box, can you write the mathematical equation for the volume of a gas varies directly as the temperature and inversely as pressure? Ready? In the chat box.
V equals KP over PA.
Oops, AP, the following instructions. In the chat box.
Sorry.
No worries. Okay, very good. We have here V equals K T over P. Now, there's a question. Ma'am, is it important that if the given is a capital T, then I need to write in capital T? Or is it okay to have it in small t? Now, if the symbol is given, you need to follow whether it's a big one or a small one, because there are instances when they mean differently. Now, let's have our first set of exam of given. The volume of the gas is 800 ml at a temperature of 25 degrees Celsius with a pressure of 40,000 pascals. Our K is missing. So let's solve for our K. We have V is 800. Our K is missing. Our T is 25 over 40,000 pascals. Cross multiply. We have 800 times 40,000 equals 25K. Now we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 32 equals 25K. Divide all by 25. We have K equals, wait first, it's 3,200. I'll multiply it by 4. Give me a moment. That's 32 million divided by 25. You have 1,280,000. That's our K. Now, let's write our K here again. Ready? Our K is 1,280,000. What's the second set of given? We're looking for the volume when the temperature is 28 degrees. Check. Same, degrees Celsius. And the pressure of 80,000 pascals. Pascals and pascals, the same. It's very important, or else you need to do some conversion. Let us have it in our formula. Ready? That's V equals KT, capital T, over P. So we have 1,280,000 times 28 divided by 80,000. Let us solve. Ready? Times 28. So we have 35,840,000 divided by 80,000. The answer for the volume is 448. What is the unit of measure? ml. So do not forget the unit of measure, ml. Now, do you have any questions?